Go with 5.09. We're still going to be applying the partial sum formula for finding the partial sums of geometric series in some real world situations. First thing I want us to do is take a look back at the triangle problem. So go ahead and actually pull out that paper, and almost all of you were very close to finishing it out. So go ahead and do that, find an answer that makes sense. Spend at least 5 to 10 minutes on that if you haven't already, and then go ahead and press play and we'll take a look at some solutions. The first thing I think all of us got to this point was realizing that if the area of the whole triangle is 1, then the area of the biggest shaded triangle is 1/4, because it's split into 4 equal triangles, and so this one has an area of 1/4. Now what you'll realize is then if you look at this triangle here is the same as this triangle here, and the next shaded triangle is going to be 1/4 of this triangle. So since this triangle and this triangle are the same, this new shaded, the second smallest shaded triangle, is going to be 1/4 of my first shaded triangle. So if I start writing out the sum here, the first triangle has an area of 1/4. The next one is 1/4 of that. So it's going to be 1/4 times 1/4, which is 1/4 squared. And so if we take a look here at some work, so this is the exact same thing we just talked about. The second biggest triangle is 1/4 of the total area of the bigger triangle, and that just continues on. So if I take a look at the first triangle, it's 1/4 or 0.25. The next one is going to be 0.25 squared. The next one after that is going to be 1/4 of that one, so it'll be 1/4 cubed. There are 5 of them. 1/4 to the 4th, and then the very last one is going to be 1/4 to the 5th power. And there are a couple ways to do this. You could just add them all up, and I think this was Daniel Paz did this, got 0.333, and you can also use the partial sum formula. So this is a geometric series because each of these is being multiplied by 1/4, so the common ratio is 1/4, and I'm summing them. So it's a geometric series, so the partial sum, so this would be the partial sum for 5 terms. So n is 5, and the partial sum formula allows me to compute this. So the initial term, a sub 1, is 1/4, so I'll have 1/4 times r, the ratio, is also 1/4, to the nth power, which is 5, minus 1, divided by r, which is 1/4 minus 1. And if you do that, you're going to get approximately 0.333. And this is an area, so this is going to be units squared, right? It's an area. And let's think real quick about why this makes sense. So this whole triangle here, the biggest shaded triangle, has an area of 1/4 or 0.25. And if you think about each of these smaller ones, the one that is just next smallest to it is 1/4 of it. And so if I were to combine all the other ones, they wouldn't even quite make up this biggest one. And so I know that it should be a little less than 0.25, and it should be a little more than it should be a little less than 0.5, then double this, and it should be a little more than just this because I'm adding on the other ones. So 0.33 makes perfect sense. The table gives some terms of a geometric sequence, and what you want to do is find the sum of the first 15 terms. So starting with this term and adding them all together all the way down so that you get 15 of them. Go ahead and compute that, and then we've got one more to look at. One more, a geometric sequence is defined recursively by the following definition. A sub 1 is 25, and then a sub n can be found by taking a sub n minus 1 multiplying by 3/8 for all n values greater than 1. First, find the partial sum, s sub 20, and then second, compute the sum from I equals 10 to I equals 20 of a sub I. So this one looks a little different. Make sure you pay close attention to where I want to start and where I want to finish, and go ahead and try and compute that. You should be able to check whether your answer makes sense in part B given what you find in part A. Okay, so in your comment, I want you to post your answer to part A and your answer to part B and whether it makes sense. Okay, maybe you say it doesn't make sense and give your reason why. That's okay. So in your comment, make sure that you post your answer to part A and your answer to part B and whether they make sense given one another. Okay? All right, I will see you guys tomorrow.